Welcome to Chapter 9. Chapter 7 gave the form somewhere to go, a PHP page that saved submissions to a plain text file and emailed a copy. That was real and working, but a text file has real limits. It can't be searched, sorted, updated, or deleted without rewriting the whole thing. This chapter has 3 parts: SQL as a standalone language first, then PDO, PHP's tool for talking to a database, and finally wiring it all together. The Chapter 7 form inserting into a real table, plus a new admin page that selects and displays everything stored there. Frame it simply for students. Every form submission on a real website has ended up somewhere more capable than a .txt file. Today they build that something more capable. Ask the question that motivates this whole chapter. How would you find all submissions from one specific person in submissions.txt? You'd have to open the file, read every line, and look for a match manually, in your own code, with no help from the file itself. A database inverts that relationship. Instead of storing unstructured text and writing code to work around it, a database stores data in tables with defined columns and gives you a full query language to ask it anything. Keep the visual comparison on screen simple. A table looks like a spreadsheet. Columns define what kind of data each field holds. Rows are the individual records. One row in a submissions table is exactly the same information as one line in submissions.txt, just stored somewhere that understands its own structure. Before any SQL or PHP, get the vocabulary locked in. These terms show up constantly in documentation and error messages, so it's worth being deliberate here rather than rushing past it. A table is rows and columns. Every column has a name and a data type that constrains what can go in it. int for whole numbers, varchar for short text with a max length, text for longer text without a strict limit, timestamp for date and time. Spend real time on primary key, usually the id column, uniquely identifying each row, assigned and incremented automatically by the database. Students never set it themselves when inserting data. Point out submitted _ at on the sample table too. That's filled automatically via default current _ timestamp. Another thing the database does for you rather than something PHP. This is the grammar lesson before the vocabulary gets used. SQL keywords are uppercase by convention. Select, from, where, insert, update, delete. Every statement ends with a semicolon. String values go in single quotes, not double quotes like PHP and JavaScript use. Column and table names are unquoted unless they collide with a keyword. Worth saying explicitly, SQL is not case sensitive for keywords. Select and select behave identically. The uppercase convention is purely for readability, so keywords visually stand out from data and column names when scanning a query quickly. Frame the anatomy diagram as the shape every query in this chapter will follow. Select what columns, from which table, where to filter, order by to sort, semicolon to end. Every SQL statement from here forward is a select is how you ask the database for data, and it's important to say plainly that it never changes anything. It's purely read-only, which makes it the safest command to practice and experiment with. Walk through the 4 examples in order. Asterisk means all columns. Naming columns explicitly returns only what's needed. Where filters which rows come back, and without it every row in the table returns. Order by sorts the results, with DESC on ID giving the newest submissions first since it auto-increments upward. This is a good slide to have students type and run each variation themselves if you have a sandbox available. Select is safe to experiment with since it can't damage anything. Insert into is what happens behind the scenes every time someone submits a form on a real website. The submitted values become a new row in a table. This is the SQL operation assignment 1, will ultimately trigger from PHP. 2 rules to emphasize. Column names and values must be listed in the same order. First column matches first value, and so on. And the id column is intentionally left out of the insert. Trying to insert a value into a primary key auto-increment column causes an error, since the database assigns that value itself. Quick reminder on quoting. String values go in single quotes, numbers do not. Students who've been writing PHP strings in double quotes for 2 chapters will want to slip back into that habit here. Flag it now before it becomes a debugging session later. Update and delete aren't used anywhere in this chapter's assignments. The form only adds data, and the admin page only reads it. But every developer needs to know these exist, and more importantly, needs to respect what happens without a where clause. Make the danger concrete. Update submissions, set email equals. With no where clause changes every single row in the table. Delete from submissions. With no where clause empties the entire table, instantly and permanently. This isn't a soft warning. Treat it as a memorized rule, not a guideline, because the mistake is usually unrecoverable. Good moment for a real story if you have one. Everyone who's worked with SQL long enough has either done this themselves or knows someone who has. It lands the lesson better than the slide alone. This slide opens part 2 of the chapter, PHP actually talking to the database. PHP has more than one way to do this. The older approach, MySQLi, only works with MySQL. PDO, PHP data objects is the modern alternative that uses the same API no matter which database system sits behind it. Be honest with students that the database agnostic benefit isn't something they'll exercise directly in this course, since we're always on MySQL. What matters more right now is that PDO was built around prepared statements as the default way to run a query. The safe approach is the normal approach, not something you have to remember to opt into. Name the MySQLi_query. Contrast directly. That function encourages building query strings by pasting PHP variables straight into SQL, which is exactly the kind. Every page that talks to the database starts with this same connection pattern. Walk through the three pieces of the DSN. It identifies the driver, host, and database name in one string, followed separately by a username and password. Slow down on attr_error mode set to error mode_exception. Call it the critical line on this slide. Without it, PDO fails silently. A broken query produces no visible warning, and the script just keeps running as if nothing happened. With it, any database error throws a PDO exception the catch block can actually handle. This is the industry standard configuration, and it's what makes bugs visible instead of mysterious. Mention where this code should live. Its own file, typically db.php, included at the top of any page that needs database access with require db.php. Name SQL injection here, even though Chapter 10 covers it properly. Students should understand from day one that pasting user input directly into a SQL string is the mistake this entire pattern exists to prevent. Two-step process. Prepare. Sends the query structure to the database with placeholders. Named placeholders start with a colon, like name, email, message. Execute, then sends the actual values separately, as an array. The database substitutes values into the structure it already parsed. The data is never concatenated into the query string, where it could be misread as code. Be direct about the rule for this course. This is the only pattern used for queries. There's no assignment where it's acceptable to build a query string by concatenating a PHP variable directly into SQL. After execute, runs on a select, the results sit inside the statement object. Fetch and fetchAll are how you actually get them out into PHP. FetchAll grabs every matching row at once as an array, the right choice for something like an admin table where you need everything immediately. Fetch pulls one row at a time and is typically used inside a while loop, which uses less memory on very large result sets since it's not loading everything at once. Point out PDO. Fetch_ASIC specifically. It makes each row an associative array keyed by column name, so $row name reads clearly instead of $row0, which breaks the moment column order changes. This is the fetch mode students should default to throughout the rest of the course. Good news for students on this slide. Displaying fetched data uses the exact same echo inside HTML pattern from Chapter 7. Nothing new syntactically. The only difference is the data source, a $row array from PDO instead of a $_post array from a form. Walk through the loop structure. For each over $rows, echo each value into a table cell, wrapped in HTML special chars. Tell students the full reasoning is coming in Chapter 10, but the short version now. The data in the database originally came from a visitor's form submission, so it could contain HTML or even JavaScript, and echoing it raw creates a stored XSS vulnerability. Frame this as the admin view, a simple table showing every submission in the database. This is exactly what Assignment 2 asks students to build. This slide is intentionally high level. Tell students that directly. The actual hands-on screenshot-by-screenshot walkthrough lives in Assignment 1, not here. This slide is the overview so the assignment steps make sense in context. 3 steps in the DreamHost process. Create a MySQL database in the panel, create a database user and assign it to that database. Then use phpMyAdmin to create the submissions table itself with the correct columns. Read the column setup off the slide clearly since students will need to match it exactly. IDID as int, auto_increment primary key, name as varchar 100, email as varchar 150, message as text, and submitted _add as timestamp, with default current _timestamp. Remind them to come back to this slide after finishing the phpMyAdmin steps in the assignment. With the database created and the PDO connection working, this is the payoff. Replacing Chapter 7's file _put _contents with a real insert requires changing only one file, process.php. The form's HTML doesn't change at all, and the confirmation page doesn't change either. Walk through the 3 numbered steps in the code exactly as commented. Require db.php to load the connection, validate the same way Chapter 7 did, then insert with a prepared statement instead of writing to a text file. Land the point clearly. The submitted data now lands in a real, queryable database row instead of a line in a .txt file. Everything from Chapter 7 still applies. This is one targeted change, not a rewrite. Step back and walk the full pipeline as a sequence. form submits, PHP validates, PDO inserts, admin reads. Each of these 4 steps is something students have now built or are about to build in the assignments. Worth calling out explicitly. The prepared statements used throughout this chapter are already the primary defense against SQL injection, even though it hasn't been named as an attack yet. The placeholders keep the query structure and the user's data permanently separate. The database never has a chance to confuse one for the other. Close by setting up Chapter 10 directly, it names that defense, explains why it works, and adds the remaining layers, HTML special chars against XSS, server-side validation hardening, and a password check on the admin page. The pipeline built this chap. Use this as the bridge slide before the recap, the full journey from flat file storage to a secure, queryable database, and the 4-step submission pipeline shown visually one more time. Good pause point for questions before moving into the deliverables slide, since this is a summary graphic rather than new material. 2 assignments this chapter. Assignment 1 has students create their own MySQL database in PHP MyAdmin, connect with PDO, and wire their Chapter 7 form to insert submissions into a real table. Remind them their own PHP MyAdmin screenshots are what the walkthrough is built around. Assignment 2 has them write a new PHP page that selects all submissions and displays them in an HTML table, the admin page. Be clear that securing this page is explicitly out of scope here. That's Chapter 10's job, and the assignment says so on purpose. The quiz is 25 questions covering relational basics, SQL syntax, select and insert, PDO connection, prepared statements, fetching results, and displaying data. Close with the framing on screen. Form, validate, insert, select, display, the full pipeline. Chapter 10.